Hello, grade 8 learner! Welcome to another video lesson in mathematics. In this video lesson, we will be discussing how to graph a linear inequality in two variables. This lesson is based on the K-12 curriculum learning competency. The learner graphs linear inequalities in two variables. By the end of this lesson, you, the learner, should be able to follow the steps in graphing linear inequalities in two variables. It's another great day to learn, so prepare your module, pen, and paper as you start watching and learning from this video lesson. Happy learning! Refer to your Quarter 2 Module 1 entitled Linear Inequalities in Two Variables for this lesson. The graph of a linear inequality in two variables is similar to the graph of a linear equation except for two things. First, the line can either be broken or solid depending on the inequality symbol used. Secondly, there is a shaded region in the graph that will describe the solution set of the inequality. Let's study how to graph a linear inequality through an example. Let's graph the linear inequality 40x plus 50y is greater than or equal to 320, which is actually the inequality describing the situation in the introductory activity in your module. We begin by observing the inequality to be graphed. Take note of the inequality symbol used. Let's process what we know. To graph the linear inequality, recall the different methods we learned in graphing linear equations. But for this module, we graph the inequality through its intercepts. We also observe that the inequality symbol used is greater than or equal to, which will tell us the type of line we are going to use in the graph. Finally, we have to choose which half plane to shade in the graph, and we do that by using test points on the plane. To graph the linear inequality through its intercepts, we have to solve for them first. We begin by solving for the x-intercept. We start by turning the linear inequality into an equation by simply changing the inequality sign to an equal sign first. Then, we solve for the x-intercept by setting the value of y to 0. That leaves 40x on the left side of the equation and 320 on the right side. To solve for x, divide both sides of the equation by 40 to get x, which is equal to 8. This means that the x-intercept of the graph is at 8, 0. Next, we solve for the y-intercept. We begin by turning the inequality into an equation. Then, we set the value of x to 0, so that we are left with 50 equal to 320. To solve for y, we divide both sides by 50 to get the value for y, which is 6.4. This means that the y-intercept will be plotted at 0, 6.4. Let's plot the intercepts on the Cartesian plane. We solve for the x-intercept, which is at 8, 0. We also solve for the y-intercept, which is at 0, 6.4. To decide which line to use in the graph, we look at the inequality symbol used. The inequality has greater than or equal to, which means that the line that the graph is going to use is a solid line. Let us determine the half plane to be shaded. In this graph, the half planes that we have to decide on are this region and this region. For your own solution, you may choose any test points from each region, but for this example, we choose 0, 2, and 6, 6. Let us first test if 0, 2 is a solution of the inequality. We begin by writing the inequality. Then, we substitute the x and y values of the point to the x and y variables in our inequality. Since 40 times 0 is 0 and 50 times 2 is 100, we have the resulting expression 100 is greater than or equal to 320. Since 100 is not greater than or equal to 320, we can say that 0, 2 is not a solution of the inequality. Let us test 6, 6. We begin with the inequality, after which we substitute the values of x and y on the inequality. 40 times 6 is 240, while 50 times 6 is 300. Adding those products together give the statement 540 is greater than 320, which is a true statement. Therefore, we say that 6, 6 is a solution of the inequality. Let us shade the correct half plane to represent the solution set of the inequality. Since the test point 6, 6 is a solution, while 0, 2 is not, we are going to shade the half plane where 6, 6 is. This means that all the points found on the line and in the shaded region are part of the solution set of the inequality. After solving, we state the conclusion of the problem. The following graph is the graph of the linear inequality 40x plus 50y is greater than or equal to 320. And this ends our video lesson. I hope that you have learned something new today because, to quote the American businessman Malcolm Forbes, the main purpose of education is to replace an empty mind with an open one. Keep on learning, dear learner, and we'll see you again in our next video lesson.